Students, we're going to explain your chord notes here. So you remember what the definition of chord is from the beginning of circles in the video, and you learned this in 8th grade math as well. Chord is a segment with its endpoints on the circle. It's a segment with its endpoints on the circle. So a radius is not a chord, because only one endpoint is on the circle. What is the longest chord of all circles? You should know that as the diameter. So since that's the longest chord, the longer the chord is, the closer it is to the center of the circle. Because the longest chord is the diameter. The shorter the chord is, the further away it is from the center of the circle. All right. So now, what can we say about chords? So obviously, that's the center of the circle there. So this long chord is the diameter. The perpendicular bisector of a chord. So here's the chord itself. Bisector, perpendicular. So the perpendicular bisector chord passes through the center of the circle, which means it is a diameter. Okay? So anytime you have a perpendicular bisector of a chord, you know the chord that is the perpendicular bisector is the diameter. All right. Congruent chords. Congruent obviously means they're the same length and thus same in length, equal length. So congruent chords are equidistant from the center of the circle, no matter where the circle is. If that chord is the same length as that chord, they're equidistant from the center of the circle. So I go from the circle. Remember, we're talking about distance is always at a 90-degree angle. Always. Because that's the shortest distance. So then this has to be congruent to this. They're equidistant from the center. That's what you're able to say with that right there. Okay. Next, congruent chords have congruent central angles. So here's my chord and there's my chord. Those are congruent. So that means there's central angle, which means you connect it to the center. You connect it to the center, and there's the central angle. Endpoint to endpoint. Okay, there's the central angle. Those central angles are congruent. And they have congruent arcs. That means, remember, there's this arc, and there's this arc. Those are equal in length as well. Okay? Which makes sense because remember, you should know that the central angle equals the measure of its arc. So if the central angle is the same, then the arc measures are also the same in issues. Okay. Next one. Theorem now. In a circle, if a diameter is perpendicular to the chord, okay, then so if I know it's perpendicular to the chord, then it has to bisect the chord and its arc. That's the same, which is what we see over here. This is the then part. I just wrote it over here, but here it is right here. So if you start with that, you know it's perpendicular to a chord. It automatically is the diameter, and it bisects the chord, and it bisects the intercepted arcs. Those arc measures are the same. Then you have parallel chords. Parallel chords have equal arc measures inside the parallel chords. So these are not the same. This outside here is not the same as this. It's way bigger, you can tell. It's only the ones that are inside the parallel chords, those arcs are the same. Okay, those arc measures are the same. Okay. So if chord AB, this right here is parallel to DC. Then arc AD, as it says, is equal to arc BC, and that refers to arc measure there. Okay. All right, that goes ahead and answers uh, anything you should need on your chords assignment that's coming up, but I'm also going to do some problems from there.